For decades, the moon sat in our sky like a dream we had once touched and then abandoned. 12 men walked on its surface between 1969 and 1972, planted their flags, collected their rocks, and came home. Then nothing. For more than 50 years, the moon waited. That wait is over. NASA is no longer talking about visiting the moon. It is talking about moving in, permanently, and the planet is drawn up as unlike anything the agency has attempted in its entire history. But here is the part that changes everything. NASA physically cannot do this alone. To build humanity's first permanent base on another world, it needs the most powerful rocket ever constructed. It needs Starship. The story of how we got here begins not in a boardroom or a government hearing, but on a launch pad. Over the past several years, SpaceX has been doing something no aerospace company had done before: flying a rocket, crashing it, rebuilding it, flying it again, crashing it again, and treating every explosion as a data point rather than a failure. The result of that relentless, almost reckless pace of development is a vehicle called Starship. And its latest version, Block 3, did something that earlier generations could not manage. It flew like it was supposed to. Previous Starship flights were dramatic for all the wrong reasons: uncontrolled breakups, catastrophic failures, systems tearing themselves apart over the Gulf of Mexico. Block 3 was different. The contrast was visible to anyone watching. The vehicle looked mature, it looked ready. NASA noticed. But before Starship carries anyone to the lunar surface, the groundwork must be laid. And that groundwork is already being laid right now in the coming months with missions most people have never heard of. A company called Astrobotic is preparing to send its Griffin 1 lander to the moon aboard a Falcon Heavy rocket, no earlier than July 2026. The lander will carry more than 1,100 pounds of cargo to the lunar surface, including a sophisticated rover designed to test the kind of mobility systems that future astronauts will depend on. A few months after that, another company called Intuitive Machines will send its Trinity lander to a region of the moon called Rayner Gamma, a place covered in bright, swirling magnetic patches that scientists have long struggled to explain. The mission will carry a science package to study those mysterious formations, along with a fleet of small autonomous rovers and a handful of commercial payloads. Then Blue Origin enters the picture. Its Blue Moon Mark 1 lander is scheduled to support a mission called Moonbase 1, targeted for no earlier than the autumn of 2026. These 3 missions, arriving in sequence within a single year, are not random. They are the first chapter of a carefully structured 3-phase plan. Phase 1 runs from 2026 through 2029. The philosophy behind it is simple and deliberately stated: stop treating the moon like a short-term stunt. NASA's approach for decades was what insiders called flags and footprints: arrive, look around, leave. Phase 1 exists to kill that approach permanently. In just the first 3 years, NASA's targeting 25 lunar missions, including 21 surface landings and 2 crewed expeditions. The agency will begin deploying radioisotope thermoelectric generators, devices powered by plutonium that can produce heat and electricity through the brutal 2-week lunar night, when temperatures fall below -200 degrees Celsius and ordinary electronics simply freeze and die. Without solving the power problem, nothing else matters. Phase 1 solves it. During this same period, the Artemis program itself undergoes a significant transformation. Artemis 3, long advertised as the mission that would return American boots to the lunar surface, has been redesigned. It is no longer a landing mission. Instead, it now resembles Apollo 9, an orbital test, a systems check, a dress rehearsal. A crewed Orion capsule will rendezvous with either a Starship lunar lander or a Blue Moon lander, possibly both, in Earth orbit. The crew will rehearse docking procedures, validate life support systems, test next-generation spacesuits, and return home without ever descending to the surface. The actual landing has been moved to Artemis 4, now targeted for early 2028. That mission is expected to touch down near the moon's south pole, a location chosen not for its scenic value but for what lies beneath its surface. Phase 2 begins in 2029 and runs through 2032. This is where the moon stops being an exploration target and starts becoming a construction site. 27 launches and 24 lunar landings are planned during this period, carrying heavy infrastructure and industrial equipment. This is also where Starship's enormous cargo capacity becomes not just useful but strategically irreplaceable. No other rocket in existence or in development can move the volumes of material that Phase 2 requires at anything approaching the frequency NASA needs. The hardware arriving during this period will reshape the lunar surface. JAXA, the Japanese space agency, and Toyota are jointly developing a pressurized mobile habitat, a vehicle weighing roughly 15 metric tons that functions like a self-contained mobile apartment. Astronauts inside it can travel across the lunar surface, sleep, eat, and work without ever putting on a spacesuit. It is designed to operate for up to 150 hours in complete darkness. Fleets of autonomous robotic vehicles will arrive ahead of human crews to do the work humans cannot yet safely do: excavating terrain, leveling ground, digging trenches, laying cables, preparing foundations. Solar arrays mounted on elevated towers will begin collecting sunlight during the lunar day. Large battery systems will store that energy. And small nuclear fission reactors, more powerful than the experimental RTGs of Phase 1, will begin powering the surface infrastructure around the clock, regardless of where the sun sits in the sky. By the end of 2032, the goal is not to visit the moon. The goal is for humans to be able to live there for extended periods and come back again. Phase 3 begins around 2033. This is the moment the plan stops being a plan and becomes a reality. A rotating crew of 4 astronauts will live on the moon for approximately 28 days at a time. They will not stay inside isolated landers. They will inhabit interconnected habitat modules, a permanent outpost, a station on another world, something closer in design philosophy to the International Space Station than to any Apollo-era capsule. Power for this outpost will come primarily from dedicated nuclear fission systems, providing stable electricity through the long lunar nights that would defeat any solar-only setup. But even with all of this infrastructure in place, the base will still depend heavily on Earth. NASA estimates that the outpost could require roughly 8,000 kilograms of food, water, air, and supplies every single month. That dependency is exactly what Phase 3 is designed to reduce and eventually eliminate. Beneath the lunar South Pole, locked inside permanently shadowed craters that sunlight has never touched, there is water ice, ancient frozen water that has been sitting there for billions of years. NASA plans to extract it. That water will supply drinking systems, hygiene, and early agricultural experiments. More critically, it will be split through electrolysis into its component elements, oxygen and hydrogen. Oxygen sustains human life. Hydrogen and oxygen combined create rocket fuel. If that process works at scale, the moon ceases to be merely a destination. It becomes a refueling station, a waypoint, a launchpad for everything that comes next: Mars, the asteroid belt, the outer planets. Phase 3 also begins testing large-scale 3D printing systems that use the lunar regolith itself, the fine, dusty soil that covers the moon's surface, as raw material. Robotic systems will heat and process that material into something resembling cement. From it, they will print landing pads, protective walls, storage facilities, radiation shields, and eventually entire habitats. The moon has no atmosphere to slow incoming particles, no magnetic field to deflect radiation and temperature swings that would destroy most materials on Earth. Structures built from local lunar soil, thick and dense, offer protection that nothing brought from Earth can easily replicate. None of this was inevitable. For decades, the moon sat in bureaucratic limbo, endlessly studied, endlessly planned, never returned to. What changed was not ambition. Ambition was never the problem. What changed was the rocket. Falcon 9 and Falcon Heavy are already carrying the first wave of landers, rovers, and science packages. They are reliable, proven, and essential to Phase 1, but Starship is what makes the rest of it possible: the permanent base, the heavy cargo runs, the continuous human presence, the vision of a moon that humanity does not just visit but inhabits. The rover missions heading to the surface in the coming months look modest from a distance. A lander here, a science package there, but they are the first stones of a foundation. The foundation of something that has never existed before in the 4.5 billion year history of this planet. Humanity's first permanent home on another world.